Hello everyone, thank you for joining me, thank you for being here. I know I'm the last thing from you and your weekend, so I'm going to be brief. My name is Soren, I'm software developer at DOM.jnl. I'm going to talk, having today a coffee talk about Microsoft Azure and about messaging services for every use case. So presented by Dom and Microsoft Azure for Technology Partner Program. The Azure for Technology Partner Program is about enable to technology partners to receive free business consultation and technical assistance to migrate to Azure, providing variation funding and helps market SaaS and PaaS offering to Microsoft Commercial Marketplace. Secondly, to get more future information about program updates, notification about upcoming events, please subscribe to Dom Daniel pages on Facebook, LinkedIn, Vimeo, YouTube, or you can find information on atp.dom-daniel.com website. If you have any question during my coffee talk, please not hesitate to leave them on comment section on Facebook or on YouTube or Vimeo. My colleagues try to answer them. If they're otherwise, I will refer them after my coffee talk. So, in information technology, everything starts with messaging systems. A big problem is that how to transfer information from one place to another. Problems goes as you go deeper. How to aggregate millions of pieces of information per second. How to spread this information between millions of devices. How to implement in real time, secure, and so on. Let's back on Azure. In Azure, we have more than 10 separate messaging services. The list is not complete, but most used are in show here. We can use for messaging purposes inside any infrastructure. Those. The general question that we are going to answer in today's coffee talk is when to use what and why. At first, I would like to suggest separate the services and group them by following method. The first group will include all the services which we use for eventing purposes, and all the others we stay as a messaging. As shown in diagram, Event Hub, IoT Hub, and Event Grid we will use in architecture for eventing purposes. So to separate events from messages, we are going to use Clayman Vaster's method, who is the principal architect of messaging services and standards at Microsoft. As a Vaster's, there are different reasons why we use messaging inside our infrastructures. So we are going to start with the notion what is a message, and later we can classify them. Some specific structured data that you want to transfer from one point to another inside any infrastructure is a message. Here is the shown not complete list of reasons why we send messages. So there are commands delivering from one series to another. There are assignments, there are reports about conditions, there are traces, transfer, query, notification, measurement, job updates, reports. These all different kind of various of messages. So the other words, they all datagrams in some cases sent from inside our infrastructures. In order to classify, let's group them. So in the first group, we have commands, transfer, query, handover, job, assignment, update, report. In another group, we have report, notification, measurement, and trace. So there is a difference between those. Let's see that. The difference between those is that the first group is about intent, is about expectation that is we have from another system. The first one is for giving me an answer. The second that I'm done my work and I transfer control to you and you continue to work. So they are intent. Here, by sending that message, the process itself may not at the destination, but the implementer who builds that system is aware of it by configuring that flow. So there are intent behind sending particular message. The second section is about facts, things that have happened in the system that report out, and nobody has any expectations. The messages, or more correctly, events are, and we don't know what happens to those. It's like a temperature sensor that just report the temperature. So those are messages, intents, and facts. We have expectations from intents. In section, we create conversations, we do control transfer, we do value transfer. Let's consider value transfer because it's more important in intents. Let's see what a value transfer is. For example, a bank account operation is a message system that message creates the value. You do a transfer of a purchase order. It's a document that flows in a system, so the value is transferred. Those messaging systems are so important because they need to be highly reliable, because you can't duplicate the information and you need to make sure that it arrives. If it doesn't arrive, then you need to make sure to figure out where it is went. So let's look at the section facts. Facts convey history. Facts look back at the past. So intent is a process and the fact is what happened. The eventing is classified as a fact, and messaging is everything else. The best way to separate those things, I think it's look at the diagram. First, we have 3 points, A, B, and C. As you see, A send message to C, C to A to B, B to A, and B to C. In the first diagram, we have about something about a relationship, which we called messaging. In the next diagram, where you see we have a point A and others. A and something distribute information to others. So it's about eventing. Let's look at events. In events section, we have 2 groups, discrete events and serious events. The discrete events are generally independent, which are countable. It's like light bulb, on or off, just to report. So it's a discrete event. If you want to see what's going on with the room's light bulb, it's on or off. You look at the only one. It's only one action. And I don't have to go and look at the whole string. Oh, sorry. And for the series, with the series, you have a totally different picture. Series are time ordered, a single data point, like a temperature of that light bulb. Reading if some peak of time may not be interesting. So it's so you are looking at the whole stream of data rather than discrete. When you work with serious events, why do you pull data towards you? Because you have a stateful compute engine. The compute engine occupies a window. The engine computes something over that window. For example, does average and then moves the window forward. So you need to keep pulling the data towards and way to pull models to grade. Discrete events are different because they're independent. You can very easily push them out, so you can report it out into a service infrastructure when none of infrastructure pieces are bounded together. That means you build a super high scale infrastructure for discrete events than it can do for serious events. Let's look at some example here for a serious event scenario. We have sensor reading device. From the device we collect readings, and they go into partitions in Gaster system. We have an analyzer here, which a stream processing platform. and pick partitions, something it's even able to filter them in this section, pull the data towards it, and then keeps doing that. An application infrastructures where we have serious event scenarios. In Azure, we can use IoT Hub with telemetry configurations or Event Hub in some scenarios. Let's look at Event Hub. Referring to our general question of our coffee talk, when to use what, let's answer why to use Event Hub. By responding to the question about Event Hub, we will use when we have scenarios like anomaly detection, analytics pipelines such as click streams, live dashboarding, achieving data, transforming processing, user telemetry processing, device telemetry processing. In all these scenarios, we have massive data which we collect from other devices or nodes, and we need to collect them in one place. In software architectures have event ingester term, which best describes event type. So let's mention that the event hub is a fully managed platform as a service PaaS, which is configuration. You need to focus on your business, not to do other things. Let's look at the traditional diagram which shows event hub stream processing architecture and separate key components. On the left side in the diagram, we have event producers, which are entities that send data to an event hub using HTTP or Apache Kafka, or it supports MQP, Advanced Messaging Querying Protocol 2, which is TCP-based, efficient, and reliable open protocol. Inside Event Hub, we have partitions. When sequence of events reach to Event Hub, it collects on more partitions. The number of partitions is separated at creation must be between 1 to 32, but in some cases we can scale up to 2000s in dedicated plan for much capacities if you need. You can use partition key to map incoming events data to a specific partition for a purpose of data organization. The partition key is a sender supplied value passed to event hub. Well, you can send events directly to a partition. It's not recommended because you put additional logical expression and we lose performance of event hub. So there we have consumer groups. The publish subscribe mechanism of event hubs is enabled through consumer groups. Consumer group is a view of entire event hub. Each consumer groups enable multiple consuming applications. If you want to write event data into long-term storage, then that storage writer application becomes our consumer group. There can be at most 5 concurrent readers on a partition per consumer group. However, it is recommended that then it's only one active reader on a partition per consumer group. And finally, we have output units or processing units. It's units of capacity that control the output of capacity of our event hub. In a case, we can scale up to 20. One output per unit is mean that you can 1 megabyte in second ingress and 2 megabyte egress, seconds egress. Let's now see the price of Event Hub. Also, Azure resources here too The pricing depends on your chosen region. And choose North Europe near our region. Here we have four pricing plans: basic, standard, premium, and dedicated. As basic and standard are simple and more commonly used, first difference between them is output unit price, where standard is twice as expensive as basic. You should have at least one output unit, which can scale up to 20. Depend on your application, ingress and egress to outputs of events. The price of the output unit for basic plan monthly is around $11, and for standard it's monthly around $12, $22. So next to that we are going to pay for a million ingress events. For a standard plan, we have a capture service, which enable directly to store collected data like into Azure storage. And monthly cost of capturing is $73. Let's mention that it's not include storage prices. It's only operations. For the next, we have um, IoT Hub. As discussed, let's answer the question why to use IoT Hub and why. The scenarios where we can use IoT Hub, device to cloud telemetry, uploading files from device, connecting and monitoring devices. In Ingress IoT Hub service for IoT devices, you can connect millions of devices and the backend solutions reliable and securely. The main important difference between Event Hub is that IoT Hub support MQTT protocol, which is widely used in IoT devices. In the pricing tab for North EU region, we have following. Here is two pricing tiers, the basic and standard, and each of them we have addition types. As you see, the restrictions of daily total number of messages and the message meta size are the same for corresponding edition types. So the main difference between basic and standard tiers are features, which we will see in next slide. Until then, please note that we have free edition type. Here is restriction for messages matter 0.5 kilobyte size, which I think is enough for something application types. And we have restrictions daily total number of 8,000 messages and restrictions for scale up to IoT Hubs units, which in other cases we can scale up to 200. For free edition type, we can't enable Defender for IoT security purposes. By the way, for every Azure subscription, you can create only one edition of free type. Let's look at the features of IoT Hub by tier. The main difference between basic and standard is that standard supports device streams, which enable of secure bidirectional TCP tunnel for a variety of cloud to device communication services. And the next main demand feature is cloud to device messaging, when you can send message to an IoT device to a cloud. Now, here is example of discrete events. You route an alarm that events towards an event distributor. An alarm is a state change that need to be reported out. The event distributor has subscriptions who are interested in this particular alarms. For implementing discrete events scenarios, Azure suggests IoT Hub with remote configurations and event grids. As we talk about IoT Hub, let's look Event Grid. Azure Event Grid is a useful scenarios for application that needs distribute event from other groups to another, react to changes that happens in another services. It also useful for filter and fan out and events to a multiple distributor. So Azure Event Grid as a fully managed event routing service. Event Grid distributes events from different sources from different handlers. A particular emits events to a topic, right now the continuous, and the other hand, even subscriber can create a subscription on that topic. Consumers can configure creation filter criteria such as the event type, event subject, and based on the data in the playground. The event source sends events to Event Grid, and Event Grid forwards related events to a subscription. I would like to talk about basic plan. There we have 300,000 operations per month and 0.6 for additional per million operations. So be careful, here is changed by operation count, not by event number. And that means event ingress is one operation, event egress another one. Let's look at this simple example for calculation. Let's imagine as we have scenarios like an Azure function is connected to blob storage through event grid to process images each time a new image is added, and the blob storage container 5 million images are created each one triggered function through event grid. You publish 5 million events to event grid, and the amount of all events are published to one HTTPS endpoint. There is, I have a simple calculation for monthly 5 million published events and 5 million delivered attempts. As we have 100,000 free operations, the total will be 5 million plus 5 million minus 100,000, which is 99 million. So let's multiply it with our 0.6, and will cost for a month will be around $6. Let's look an example standard messaging scenarios device command, and that runs through some cloud gateway like Azure IoT Hub, and we get messages from devices and backend processes. But for each device, we need to lead a queue because device pop up and pop in of configure for network. They switch networks, they're roaming. That means you want to send messages through them. We can't carry out condition continuous connection. When the device is offline, we need to have a place where the device can pull that from. As long as device is offline, the queue disappears. It has almost zero latency. You send a message and data goes through it. For implementing standard messaging scenarios in Azure, we have IoT Hub for IoT devices and heavy artillery service bus. Let's start. Azure Service Bus is a secure, highly available, and reliable platform as a service enterprise. Integration message broker, synchronous transfer for data between applications. It is useful when an application wants to send directed messages like commands to other applications and expect them to perform these commands. For example, in e-commerce application, after receiving an order, sender sends directed messages to procurement service to procure product, to warehouse systems to pick a product, and to CRM system to notify customer. Let's look how it works. A sender sends message to a queue. Queue sends back acknowledgement receipts after successfully replacing the message. The other side, receiver connect to the queue to retrieve a message, and after completing the processing, it sends back an acknowledgement for a message deletion. In a case of error, a message can be moved into that letter queue, we say DLQ, to discard or letter consumption. Uh, Service bus split into queue and topic. Azure Service Bus Queue is order timestamped message storage. It can be used for a point-to-point communication, which means a single producer of messages works with a single receiver that reads from a queue. And Azure Service Bus topic is also a queue internally, but designed for point to multi-point communication. This means we have a message publisher, writers writing messages to a topic, and each topic subscription receives copy of these messages. And this is Azure Service Bus pricing list. It has three main plans: basic, standard, and premium. The difference between them is features. For a basic plan, it bills by per million operation, $0.05. So if we compare it with Azure Event Hub, where for a basic plan it's 0.015 per million events, and for standard plan there we have 0.03, which is much cheaper. It because Event Hub designed for event streaming. Let's look there. We have operations with charging on per million operations, not for events. It means that as an event grid, we have event ingression another operation, event egress another. Ingress and egress is different operations. So starting from standard plan, we have base charge, and that means even without sending any messages, it will charge us $0.035 per hour. It's include 13 million first operation for a month, and after this 13 million operation, it will start to bill as $0.8 for per million operations. There is the feature tab. As you see, we have messages size restrictions. Choosing basic plan, we can use only service bus queue and schedule messages. For using service bus topic, we should choose a standard plan. And we can also use transactions, the duplication, and sessions, forwarding to, and send via features. For a premium plan, we have additional redundancy features too. Another example is workflows execution. The information from our devices is used in backend processes. Here we have state machine, that is workflow manager, is process our work and transfers the information to according and stuff, which are standing software with pre-built interfaces that does work instead of us. For building scenarios like this, we can use Azure Logic Apps and Azure Service Bus, as we have looked. Now, I want to speak about Azure Logic Apps, which is used for creating, running automated workflows. Azure Logic Apps helps you automate and orchestrate tasks, business processes, and workflows when you need to integrate apps, data systems, and services across entire organizations. For example, you can automate, process, and route orders across on-premises systems and cloud services. Send email notification with Office 365, move upload files, monitor tweets for a specific subject. Here we have mainly two main plans, standard and communication. For a standard plan, we pay for virtual CPUs and for memory allocation. But in communication plan, pricing model is different. Here we pay for every action by carefully payment is for every action compared to Event Hub or Service Bus, where we have the payment per million action or event metrics. And we need to pay for every concurrent tool, connector tool. Look at the final option that we have pay for data size by month tool. We have additional pricing for specific cases too. Let's modify previous diagram as a hybrid cloud. Putting a firewall, a hybrid cloud combines public and private clouds. Here we can use message queues, topics, and to send messages without concerns of consumer availability, and helps balance variety of workflows throughout. One of the scenario of a cloud is when you set up a topology of routers. You have specific queues assigned to a specific sites. You put a message in there, and the message pop up in a queue, and the site pulls data back up. The scenarios where we have firewall restrictions for messaging purposes, we can use Azure Relay. All right, so let's start off by talking about Azure Relay services. Now, Azure Relay service allows you to securely expose service that rise inside your corporate network without having to modify or open a firewall connection. Now it sounds like magic like. The relay service useful in scenarios like traditional one-way request response and peer-to-peer communication, bidirectional socket communication across network boundaries. The main features is that Azure Relay service have a native configuration of VPN settings. Let's look about how it works. As mapped in a diagram, you have got an Azure Relay service in the middle, and you got cloud app or web app that needs to access VCF services, which locate in private network or corporate network. Here is Azure Relay as a proxy. Basically, you install the piece of software in your network here, and that hybrid connection manager is going to connect to the out with the help of this software. Azure Relay service using an outbound connection, so this is going to open two-way communication between the software inside your network and relay service running outside your network. It's a bidirectional socket. For a hybrid connection, it's charged per listener monthly, and after 5 gigabyte transaction, it will charge $1 per gigabyte transferred information. And for VCF relay, it charged by hours 0.1 for every 100 relay hours. And for messaging, for messages, 0.01 for every 10,000 messages. Here is the same with phones, IoT devices, and browsers, but here we have more specific services too. For implementing scenarios like messaging to phones, browsers. We have Signaler, Azure Signaler, Notification Hub. Two. As we have talked about last two, let's talk about now Signaler and Notification Hub. Starting from Notification Hub, which enables us implement scenarios like sending breaking news notification to millions with low latency, sending location-based coupons, event-related notification, push promotional contents, notify users of enterprise events such as new message or work items, send codes for multi-factor authentication. The main advantage of Notification Hub is that it gives us opportunity to easily implement push notifications sent simultaneously to millions of nodes which use systems like iOS and Android or Windows. The pricing for Notification Hub is simple. Here we have three plans: free, basic, and standard. We have basic change for basic. And, let's look at first for basic and standard. It's include around 10 million for basic and standard, and for additional push we have chart here. There are same namespace restrictions. I think it's enough for a free plan. The main restriction by a plan is device count. For a free we have 500, for a basic 200,000, and for standard it goes up to 10 million. As you know, Signaler is a free and open source software library for ASP.NET, and it allows us to code to send asynchronous notification to client-side web applications. Now, Azure suggests Signaler as a fully managed, meaning you don't must to worry about hosting, scalability, load balancing, and other such details. You can use Azure Signaler with high-frequency data updates, gaming, voting, polling, and actions, dashboards, and monitoring in financial purposes or in multi-game player leaderboards. We can use it on chat systems, for example, in live chats, real-time scenarios. Here we have two plans, free and standard. For a free plan, we have 20 concurrent connection per unit, limited daily messages, and limit to have more than one. But when you pay a daily $1.61, you break restrictions to max units, having up to 100 units, and have up to 1,000 concurrent connection per unit. You can have unlimited daily messaging, which frees for free 1 million messages. After that, it will bill $1 per million. For messaging scenarios, the price is higher than we have in Service Bus. So, thank you for staying with me. I think we need to have another coffee talks about messaging services by details for every service too. And if you have any questions, I will be glad to answer now. Please put them on comment section. I will have your questions. Oh, okay, there are no. So have a nice day. Thank you for joining with me. Goodbye.